This lesson helps you understand congruent figures. Congruent figures have the same size and shape. Corresponding angles and corresponding sides of congruent polygons are congruent. The tick marks tell you which sides are congruent. The arcs tell you which angles are congruent. When you name congruent polygons, list the corresponding vertices in the same order. So for this diagram, start at the vertices of the corresponding angles. Then across the congruent sides, and the congruent statement is TVYR is congruent to KPML. You can turn this around. A congruent statement can tell you which parts of the figure are corresponding. From this congruent statement, you can see angles A and K correspond. Sides AB and KL, angles B and L, and sides BC and LM. You can show that triangles are congruent by showing that their corresponding parts are congruent. The first method is to show that all three corresponding sides are congruent. This is called side-side-side congruency, and it's abbreviated SSS. So in this diagram, you can see triangle ABC is congruent to triangle KLM. The second method is to show that two sides and the included angle are congruent. Included means the angle is between the two sides. This is called side-angle-side congruency, and it's abbreviated SAS. In this diagram, these two sides are congruent, and these two sides are congruent. Then the two angles at point M are vertical angles, so they are congruent. And the two triangles are congruent by SAS. The third method is to show that two angles and the included side are congruent. Included means the side is between the two angles. This is called angle-side-angle congruency, and it's abbreviated ASA. In this diagram, these two angles are congruent. The triangles share a common side, so it's congruent to itself. And these two angles are congruent. So the triangles are congruent by ASA. This lesson helped you understand congruent figures. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.